I was reviewing the set theory textbook the other day and was making some flashcards using Anki. This is a flashcard program that uses spaced repetition to test you on cards. Um, Spaced repetition, like if you get a card right, here I'll do an example here. The answer is, and then this is a closed deletion, okay, 42. And I add that, and now in this deck, if I study it, this is an example of a card. Now that's blanked out. If I show the answer, it says 42. Okay. If I get it right, then I can say good, and it'll ask me in 10 minutes. If I get it wrong, it'll ask me in a minute. And so there we go, good. And because it's the only card, it'll just ask me again right away. Um, and then if I got it again, it would ask me in a day, and it keeps increasing the length of time. So this is as opposed to something like Quizlet. Um, but where Quizlet is unmaintainable in the long run because it's not spacing things out. So as your collection grows in Quizlet, it's just unmanageable. You can't have thousands of things in Quizlet because it doesn't schedule things like this. Um, so that's just what Anki is for context. So I was making some flashcards here for for these things, and I was thinking, okay, how about if GPT-4 could make those flashcards for me using a program that scans the PDF, extracts the definitions, and has it make those flashcards. So that's what I did. That's what I'm showing now. So the first file here converted the PDF to PNGs, to images. The second file converted the images into theorems, calling GPT-4 and giving it a prompt. This is the prompt for that. And then cleaning up those theorems in the output, the theorems and definitions, sanitizing them in certain ways. It was an iterative process. Um, and then adding closed deletions to them. Again, from GPT, that requires a separate prompt. Yeah, create closed deletion flashcards from the following mathematical definitions and theorems, right? And then this part here is replaced with um, the actual theorems that it's supposed to apply them to. And I do it in batches of 10. Um, so after that, then I convert the closed deletion syntax that I had it use, which was simple, into the actual syntax, um, which is like this syntax, which it was failing to produce earlier, which is why I had to simplify the syntax for it so that it could actually do the task. Um, and then finally, this last file creates the deck um, based on that text using this Python library genanki. And the output is right here, output deck, and I can open it here. Now it's not perfect. A lot of them don't even have closed deletions in them. 33 of them were skipped because of that. I only started making this program 2 days ago, 2 afternoons ago. In fact, I can show. Um, and this, by the way, the files here do not reflect what I would do in a professional setting because this is just for me. But um, here was my original. See, it's on the 9th. This was 2 days ago. Um, and then it got too cluttered, and I was like, okay, I'll just make a second folder, same thing, but refactoring things, and then a third one refactoring things, and that's where we are now on the 11th. Um, and yeah, so if I go to this deck, oh, I just named it some random numbers here for now. It's not complete, but I'm showing it anyways, just as a good example, because I might wait to work on it a bit later. So here's an example of a card, right? Let I, being a subset of the natural numbers, be an inductive set, then I equals blank. then it is the set of natural numbers. So this was a totally valid um, flashcard, and most of them are totally good like that. Um, so yeah, this is just an example of some of my work.